Unfortunately, I did use Grunt for my slides, but my port is LEET 1337. So hopefully that makes up for it. All right, but I will probably use Grunt after this. Okay, so my name is Josh Robertson. Actually, first, if you want, or you should pull up my slides. That doesn't cut off. Okay, there we go. These are my slides. That is a 0 and a capital L. I guess I don't have to talk that loud. I have some demos that will interact the keyboard, and so I highly recommend that you pull up my slides. All right. Let me know if you want them. Okay, so my name is Josh Robertson. For you locals, I interned at a place called Domo for 3 months during the summers when I wasn't in school. I'm an open source enthusiast, but unfortunately I haven't contributed much yet, but I will contribute hopefully soon. It's been kind of busy because I freelance off time and school, so it's been kind of busy, but I want to contribute, and that was one of my goals for this year. Snowflake, I just put this on there that was just my first Canvas experiment. I just wanted to get that out there, and it's on my GitHub. And CodePen, I just will be using CodePen for all my demos because I love CodePen and it gives back data and stuff like that. And also, I got featured on their front page one day randomly. It was just like a math homothetic centers. That's the math term, and I guess they liked it. And I also got tweeted out by Chris Coyer, which is awesome. Okay, so topics that I'll be covering for you. How many have used Canvas here? Like, pretty well, that know it pretty well? Okay, well, the beginning, I guess, how many actually know the API and stuff? That's what I'm trying to say, sorry. Okay. All right, so not that many of you. I'll just briefly go over it so that when you see my demos, you won't be too confused. My demos aren't that complex, and I try to write my code pretty simple for this. And we'll talk about basic trigonometry, so we can animate stuff like cosine and sine, and basic motion, so velocity and acceleration. All right, so first off, what is Canvas? It's a graphics with JavaScript, so it's an HTML5 Canvas is an easy and powerful way to draw graphics using JavaScript. And Canvas can also use a thing called context. Well, you use context. So you can issue commands through JavaScript so that you can draw stuff and do whatever you want. So one little forewarning, I do have lots of demos, which I think is a good thing because Canvas, I think, is better to see the demos. All right, so this is the drawing API. These are the main ones that I'll be using. They're the simplest and basics of Canvas. 2D, of course. There's, of course, like WebGL and stuff, but stroke style will just change the color. I just want to go through them briefly. Stroke style will change the color of a line. Fill style, if you have a rectangle or something, it'll fill in the color. They're all pretty basic. Line width is the width of a line. Begin path, so if you usually always begin with a begin path. That's just the proper way to do it. And when you're drawing something, so if you're going to draw a line, you begin a path, and then you say move to, which is basically, if you imagine it like a drawing thing, like I said, move to will just pick up your pencil and put it somewhere. Otherwise, if you're using line to, then it'll just draw all the way across. And you give it an X and Y, so coordinates in the Canvas system, or the canvas. And stroke, you always just stroke it, which is basically just draw at the end. Arc will give you a circle, so remember it's X, Y, radius. The start angle is usually 0 because that's just where you want to start, and then the end angle. So this could give you a circle, oval, and then clear rect will clear your canvas, so just stop it, and fill rect will draw like a rectangle with the X, Y, width, and height. So those are pretty basic, and then save and restore. I don't use it much in my demos because I just use objects and just store everything in that. But if you have just a huge block of lines and stuff, then you want to save it and restore it. And if you have multiple colors, I guess, then you want to save it and restore it. It's basically just putting it away, and then you can restore it later, so you have just, say, multiple colors. So these are pretty basic. And then just tapping into the API, this is how you can all see that, right? Okay, if you don't, you have hopefully my slides pulled up. So tapping into the API, you say var canvas is usually the normal part, and then you say document.getElementById. If you, in the HTML, you'll see in my demos that you give it ID if you want, or you can query select it, but you can just say ID is the example, and then you give it the context, so canvas is the variable name, and then you get context 2D. So clearrect is the one that, these are all just simple, like I said, but it's basically just clears and draws it, clears and draws it, clears and draws it, like stop motion, because you don't want pixels left over. Unless you do want pixels left over, which you'll see in my first sign demo that you just want to leave a trace of it, basically. But if you're going to be animating and stuff, you'll usually clear it. All right, so trigonometry. People say, oh, I'm not really good at numbers, but you actually hardly even deal with numbers. There's no need to be scared of math. Even if it's been a while since you've taken a math class, there's no need for you to be scared of it. Most Canvas is usually just visualizing shapes and relationships, and you deal with positions, distances, and angles, and you never actually see the numbers. 90% of the trig you need in Canvas and animating is just math.sine and math.cosine, and I'll talk about it more once I start getting into my demos. And I said beforehand that I'll talk about radians and degrees just a little bit, is because Canvas and I think computers just like radians more. So normally we think in degrees, and that's how we normally think in, so like 90 degrees, 180 degrees. And 1 radian may seem like a weird number, 57.29, whatever, but it actually works out with 2 pi, because 2 pi is a full circle. You can see it's a full circle, and pi is half a circle. You can see that 2 pi is actually 1 radian. It equals 6.2, the number radians. So it equals out. That's what I'm just trying to say. But if you don't want to think in radians like pi, 2 pi, pi divided by 2, you can convert it into a formula. So say, I don't know what 32.2 degrees is in radians, then you can convert it in this formula. So radians equals to degrees. So degrees, you just give it in a number, 90, 80, 180 degrees, whatever. And then you multiply by math.pi divided by 180, and that's the proper way to convert it into radians. And then when you give it, you actually give it the radians so that, because the computer won't think in degrees, and then vice versa, but you hardly use the other one. So just still simple, half a circle with radians. You get into the API, you tap it in the API. So I just gave a variable radius to 50, so it's not just some arbitrary number in the arc. So begin the path, and then you do arc. So I just do canvas.width divided by 2 and canvas.height divided by 2 just to center it. You give it the radius, and then the start angle, and then math.pi is half a circle. And the same thing, it's the exact same thing. You just multiply by 2, which is otherwise known as 2 pi. It's math.pi times 2. And 1/4 of radians is just divided by 2. So half circle with degrees, this is just using my formula that, well, not my formula, but the formula I gave you. So var degrees equals 180, and then radians equals to degrees multiplied by math.pi divided by 180. And as you can see, I actually give it the radians, like I said before, because you give it the radians. And that's half circle. A full circle, you can see, is 360 degrees. And 1/4 of circle is 90 degrees. And as you can see, the circle, it actually starts going down instead of up like you'd normally think, so this is the classic coordinate system. Just a little background on Canvas, and this is what we've been taught, like when I'm graphing in school, and I'm still in school, so I know that we still use this, that the center of the page is 0, 0, and then positive y goes up, negative y goes down, positive x goes right, and then negative goes left. Well, the graphics coordinate system, I think it's graphics coordinate system, just computers, and Canvas, the top left is the center, so 0, 0, and positive y goes down. So it's kind of confusing sometimes at first that the positive goes down. and then positive x is just still right, but it starts in the top left. I was confused at this because I'd start trying to animate stuff, but it was off my screen, and I didn't understand why, and that's why, is because it's in the top left. But it's also backwards for the classic angle system. The classic angle system, which I was showing you, positive degrees goes up and negative goes down. But as you can see in my circle demo, it actually went down. The circle started going down because canvas angle system goes positive goes down and then negative goes up. All right, so let's start talking about sine waves. Okay, so this is how a sine function behaves. As you can see, the radians is on the top graph, and then the degrees is on the bottom. I just show them both. You can just visually see how a sine wave will work into a circle, and you can animate it that way. So you can see that pi is half a circle, and then 2 pi basically equals, it is a circle. And then vice versa, 360 degrees, 180 degrees is half a circle. So I made a little example, which is what I was going to show you. This is in CodePen. And this is what I was saying beforehand. If you have my slides open, you can see it better. I don't clear it because it leaves a trace. And you can see here, the range is 100, so how far the sine wave goes down and up, which is otherwise known as the amplitude if you're technical with it. I just call it range because I like the range. It makes sense to me. Speed x is how fast it goes right. The sine wave starts animating, and speed y is up and down, so how fast it animates up and down. Luckily, we had request animation frame 60 frames per second talk by Jeremy, so you now understand that request animation frame is 60 frames per second. It tries to go that speed. So we begin the path, we move it to wherever we want, in this case just 0 for the x, and y is center y, so we can have it centered. And then in the request animation frame, we increment the x to plus equals to speed x, so that it'll always just keep moving. And then for the y, we set it to center y. That's just where our y is, so we could have done the old y. And then we add the math.sine so that it actually will do the sine wave, which you could see in the last graph. And we give it the angle, which the angle is the radians, which I was showing you. And our angle, you just increment it with the speed y, so that it'll move up and down as fast. And then you multiply by the range to see if it goes up and down. And then the rest of these lines don't matter. Can't even see the mouse. But if you can tell that if I change this right here, then it will change, and that's what I was talking about, of the range, otherwise known as the amplitude. Okay, so now that we have sine waves, let's actually animate with sine waves. So this time we're actually going to clear the canvas instead of just leaving that trace. We're going to clear the canvas. Of course, we use request animation frame with all our animations, like a game loop for, it's just a game loop. And then we'll just create a circle to animate with it, because in a sine wave. And so we'll give it an x and y, and we'll loop it over so you can see it multiple times, and then we'll just give the ball a random size so we can see it in action. So here's the sine wave. I didn't actually make the canvas to adjust the width and height of this, but if you have it pulled up, you can see that it is going in a sine wave, and it's animating that way. It doesn't leave a trace because we're clearing it. And this might be a little confusing. Well, not this part. This is just an object. I just use an object. I like to use objects to create my balls and stuff. Okay, so this might be a little confusing because I have a set timeout and a request animation frame. But because you were saying how you don't use both, you either use request animation frame or the set timeout. But the reason why I'm using a set timeout is pretty ghetto. I'm just pushing a ball into an array. Well, and then it'll just send a new one. If I had to do this different, I'd just have it so when it gets to the end of the screen, just have it send another one or the same one. But that's why I just don't get confused with the set timeout. I'm just pushing it into an array. And in my request animation frame, this is where I actually paint the otherwise known as pushing the ball. And I just use a for loop, which the balls is right here. So 25 balls, it'll just send them in. And the range is the amplitude otherwise known. And the get random number function. So You can see that later if you'd like. All right, so now that we have sine waves, let's actually do some motion and animate it. So those are pretty boring. I know that everyone's probably thinking, why would I ever animate with sine waves? It's just like a sine wave, right? Well, we can start getting into motion. So what is velocity? This is a math term, physics, I guess. And velocity is just, in its basic term, is something that moves. But like I put up there, velocity is speed and direction. So it's a direction. I bolded it because you have a speed and a direction. That's what the velocity term is. Velocity on x is just a horizontal movement, and velocity on y is just a vertical movement. And I bolded vx and vy because when people are programming, they just write like .vx or .vy. So I remember when I was looking at Canvas animations, I didn't really understand. I wanted to know what the acronym meant, but I didn't know where to find it. And so when I started studying Canvas and reading books, I found out it just means velocity on x. So remember, it has a direction. And as you can see here, if you have my slides pulled up, that they do actually put .vx or .vy. Okay, so velocity on x-axis. This is just basically a simple demo. You already probably know what it's going to do, but the rectangle is just going to move on the x-axis, just velocity on x-axis. That's all it is. It's just moving, and I have it come back around when it's done. So this is the logic. The fill rect, it looks confusing, but really I'm just trying to center in the page so that you can, it looks better. And that's just my boundary logic to send it back through the if. You'll see that in a lot of my demos, like all of them, because I like to see it come back around. But a key thing here to notice is I have two variables. I have an x, so 0, and I have a vx, which is equal to 2, so basically the movement speed of the rectangle on the x-axis. And then when you actually give it to it, you just give it x. So when you give the variable the x, you just give it an x, and then you x incrementally equal to the vx. So you add it to that. And so that's the x. Oh, and I also just put this one in there for velocity on y-axis, on both axes, which is kind of velocity on both axes. I'll get into that right after this slide, but what it is, just so I can ease you into it, x is equal to 0, y equals 0, so you set them both to 0, just so you can see it, and I give it a speed of 1 pixel, so on both vx equals 1, vy equals 1, and then in my request animation frame, I give the arc, the circle, x and y, and then I just add equal to the vx, x, and the y both ways, so it just moves that way. Okay, but we kind of cheated with the definition of velocity because we have two different speeds, so they could be two different speeds. But they're both one in this demo. But we have two different speeds in two different directions. So what if we have a value for speed and an angle for direction? So say we want to go 45 degrees and move it 1 pixel. But there isn't a Vx or Vy anything similar to that definition. How would we do that? We just give it 45 degrees. That would be 45. That's how fast it would actually be going. So we're going to have to do a little bit of math again with the math sine and math cosine. I bring in this, it's angular velocity, but I bring in this triangle. So come back to junior high math, which is trigonometry and geometry. So we have an angle, and then math.sine. So I didn't explain this, but sine is opposite over hypotenuse. And if you don't know what that means, I'm sorry. But I actually have a demo that I made that's pretty good to help. And cosine is adjacent over hypotenuse to the angle, of course. Okay, so we're going to have to get back to math. So we're going to have to set an angle. So the angle's 32.3, whatever you want, whatever angle. This is why it's good, because it's the angle. Before we couldn't just give it an angle, but now we can just give it some specific angle. And this is in degrees, so we do it into the radians formula. And now we set our Vx. We have to give it to the Vx, not the x. Last time we gave it to the x, which made it just do the sine thing, but now we're going to actually give it to a different variable, which is Vx. So we're going to give it to Vx and say math.cosine, give it the angle, so radians, and then we multiply it by the speed. So whatever speed we want. Before it was range, but let's just multiply it by the speed this time. And so cosine, as you can see, I said it's adjacent over hypotenuse, and so adjacent, if you can see my pointer, and hypotenuse. So that would be this one right here, which is x. So I name it Vx, and then the Vy, which is sine, we give it the angle, and then we multiply it by the speed. So I bought this like $25 app to show you this ruler. And I'm not kidding either. I haven't used it since. And I set the angle to negative 45 degrees because, like I said before, the angle system is backwards with canvas. So I just set it to negative 45 so you could see it. And this is the demo right here. That's 45 degrees. And if you don't believe me, we can change this right here to 90, and we all know what 90 degrees is, up and down. Okay, so now we understand this. We have a speed, so we have a different variable for speed this time. We have an x and a y, so we just set it to 0 in the top left corner. And we have the object that I just create the ball with. You don't have to do this. I just do it so that I can have multiple balls and whatever, multiple circles. And so we clear the canvas so we can animate instead of just leaving nasty green trace. If you took that out, you would see. Okay, this right here can help you if you don't see it. I'm sorry, but you can pull it up on your laptop. It shows you I just left it there for the demo. If you ever come back to the demo, it'll show you which one's the sine, cosine, adjacent, such. Okay, so then we have the radians like I showed you before, the Vx and Vy, and we just do the same thing like always. We just plus or equal to it to the Vx, the x, and the y, so it'll start moving. This if statement is it's just boundary logic, basically, so you can just see it come loop around. So we got velocity. What is acceleration? So most people think of acceleration as speeding up and speeding down, and you wouldn't be wrong, but it's also a value and a direction. Just like velocity, it has a direction. So velocity changes the position of an object. So you have an x and y, it's just sitting there, and then Vx and Vy velocity will change the position of it. So it'll start moving, but it's moving at a constant speed. Acceleration changes its velocity. So now we have three variables. We have an x, a Vx, and an Ax. So now x is just 0, just for basic. And then we have a Vx, which will go to the x, so these two. So it'll start moving it constantly. And then the Ax is with the Vx. So it's a value that you add to the velocity property, which I'll show you in this demo. So you can see here we have three variables. X is equal to 0. Vx is equal to 0 just for simple. So it's not moving at all. It's just there. But now we have an Ax, acceleration on x, and we set it to 0.04. And then we just do this. So we add x equal to the Vx and then Vx to the Ax, which I was saying before. And you will see this will start to speed up pretty rapidly. So that's acceleration because it's going to on the Vx instead of the x. They were both 0, but then the Vx was adding to that, and now it's just going crazy. And that's my boundary logic right there. And now we have it on the y-axis, which is literally the exact same thing, just change the variables. So I didn't even have to have this in there, but just so that I can show you, it is the exact same thing. And if you wanted to look at the code, I just plug it in for y in the arc, so the circle. Okay, so now angular acceleration. This is just like before. So I just set the x, y, Vx, and Vy. They all just are 0, so it's just sitting there. So you aren't too confused. But normally you would have Vx and Vy just moving, and then you add the acceleration to that. But for now, let's just set it to 0. It'll start moving right off the bat anyways. So we have our angle, so 45 degrees. And our force, I use the word force for the variable just so I sound smart. I don't know, you could just name whatever. And speed, acceleration speed. Okay, so then we go, and this is actually going at 45 degrees, just like before. If I change, can anyone see where that? Okay, I can't even see from here. If I add it to 90 degrees, you will see that it will, if it ever reloads. Did I lose Wi-Fi? I don't know if I lost Wi-Fi. But let's pull this out. This time now it's a little different. So we have our radians. We plug it in the angle just so we can switch the degrees up so we can do some random degree if we want, 32 degrees. And so now we have an x and y, so they're 0 right now. We have a vx and vy, and they're both 0. But the vx and vy both are adding equal to the ax and ay, so that and this time instead of giving the math.sine and math.cosine on the velocity, we give it to the acceleration, which will make it do basically the same thing as velocity, but this time we're adding it to the velocity, the acceleration to the velocity, which will make it do that because we have, and it goes crazy. So now that we know acceleration and we know velocity, let's add them together on both axes. So we have acceleration and velocity, and we're adding it on x and y on all of them. So at this little demo, you can control it with your keypad if you have my slides open. And basically, so if I just move this around, you can see if the scroll bars, and it'll just loop around and it adds acceleration. Okay, so how do we actually do this? Okay. So we set our variables all to 0, even the ax and ay. The ax and the ay have to change because you're adding actually force. So they're all at 0, it's in the center of the page. The x and y are center x, center y, just so it's in the center. It looks good instead of the top left. And reactiveness, so when you actually touch it, how much are you going to add to the acceleration, otherwise the velocity? So it's just 0.1 is pretty good. It's even a little quick. I just do my object again for the ball. You can do whatever you want. You can actually manually do it instead of just doing that, instead of just creating a new one, but I like creating a new one. Okay, so now we add an event listener on the document. So on key down, I just have a switch of all the up, down, left, right. Konami code. Oh, wait, no. Just kidding. Okay, and then we just add it. So if we're going to go up, then we're going to minus the reactiveness. And then if we're going to go down, vice versa, left, right, and to the AY. So we set it to the AX and AY so that you set it to the velocity. But you'll see, but the thing is if it will just keep going, so it'll start going quicker and quicker. But we have to, when we let go, we're going to have to set the AX and AY to 0, back to 0, and just keep the velocity keep moving. That's why we have 3 variables. And this circle has been going the same constant speed since I last touched it, because it's on the velocity. You could technically add like gravity or whatever you want to slow it down, but it's just going the same speed. And the AX and the AY are the only one that determine how fast and where it goes and such. So we clear it, we have some boundary logic, and we do the same things as before, and we get this sweet velocity acceleration demo. So thank you. If